Hello girls, I hope you're staying safe at home. To continue with chemistry, today we are going to start a new chapter, Analytical Chemistry. Okay, now analytical comes from the word analysis. Okay, and you know the meaning of analysis, that is, you analyze, you see what it is made up of. So when we talk about analytical chemistry, we are talking about proving that a certain compound given to you is made up of a positive radical, say copper, and negative radical, say sulfate. Okay, so you are analyzing, that is, you have to perform certain tests in the laboratory and then find out what chemical compound or what salt is given to you. Okay, now when we talk about analysis, we are talking about the determination of the chemical components in a given sample. Okay, a sample is given to you, so by various tests you have to tell us what that compound is. Okay, that is, you have to find out what is the metal ion there and what is the non-metal ion there, or what is the positive radical and what is the negative radical. So there are two types of analysis in chemistry. One is qualitative analysis, where you have to find out the unknown substances, and another one is quantitative analysis, where you have to determine the composition of a mixture, that is, what it is made up of. Now, qualitative analysis, that is identification of unknown substance, is done by carrying out different tests in the laboratory. Okay, different chemical tests with the help of reagents. Now, what is a reagent? A reagent is a substance that reacts with another substance, or basically a reagent is a chemical compound. Okay, now remember, alkalis are very important laboratory reagents. You know, alkalis are bases which dissolve in water. So when alkalis are added to certain salt solution, different colored precipitates are formed of metal hydroxides, so a metal ion can easily be identified. Now, colors of the salt and their solution. The salts of representative elements of the periodic table, remember the representative elements means group 1 to 13 to 17, are colorless, while those of the transition element, that is salts of groups 3 to 12, are generally colored. So different colors of colored salts help in the identification during qualitative analysis. Okay, so let's take a quick look here. Colorless ions, you can see ammonium, sodium, potassium, calcium, magnesium, aluminium, lead, and zinc. And colorless, these are all positive ions, and colorless negative ions or anions: chloride, sulfate, carbonate, nitrate, hydrogen carbonate, sulfide, bromide, and acetate. Okay, and then we have colored ions. Like, just looking at the color, you can easily say which metal ion is present there. So if it is cupric, it is blue in color. Ferrous, light green in color. Ferric, yellowish brown in color. Nickel, green. Chromium, green. Manganese, pink. And negative ions, permanganate, pink or purple in color. Dichromate is orange in color. And chromate is yellow in color. So when alkalis are made to react with the metal cations or the metal positive ions, it results in the formation of their hydroxides, which comes out as precipitates. You know, precipitate means it is a solid. Now, you already know what precipitation reaction is. We have already talked about it before also, but anyway, we're talking about it again. You know, precipitation is the process of formation of an insoluble solid when two solutions are mixed together. When two solutions react, one of the product is an insoluble solid, and that reaction is known as precipitation reaction. And the solid formed is known as the precipitate. So the compounds form precipitates which are insoluble in water. Now, action of sodium hydroxide solution on certain metallic salt solution. Children, you'll get these as equations, and the color changes are very, very important. Now, sodium hydroxide, also known as caustic soda solution, is added drop by drop to the solution of a metallic salt. Okay, so you know sodium hydroxide is also in solution form, and the metallic salt is also in solution form, that is, it is dissolved in water. Okay, so the metal hydroxide formed is a precipitate, so it gets precipitated. So, and the color of the precipitate identifies the metal ion. So the color of the precipitate will tell you which is the metal ion. Okay, so some precipitated metallic hydroxides dissolves in excess of hydroxide solution, but some does not dissolve. Okay, so here, now calcium salt, if you are testing for any calcium salt or calcium ion, now here it is colorless, it does not have color, basically it is white in color. Okay, so calcium nitrate is given to you, and you are supposed to find out the metal ion. Okay, so what you do, you make a solution of calcium nitrate, and then you add caustic soda, that is sodium hydroxide, to it. There you will see a white colored precipitate is formed. What is the white colored precipitate? It is calcium hydroxide, and sodium nitrate you will find in solution only. And when you put more of sodium hydroxide after the formation of the white precipitate, you will see that it is white and it is sparingly soluble in water. The color of the precipitate is white, and when you put excess of sodium hydroxide, that is the alkali, it is soluble, little bit soluble in the alkali. Now ferrous salts, iron. Okay, ferrous sulfate you take and you add sodium hydroxide. Remember, both are in solution form. You will get a dirty green gelatinous precipitate. Gelatinous means it is jelly like. Okay, and sodium sulfate will be formed, and when you put excess of sodium hydroxide, it does not dissolve. Okay, it is insoluble. Similarly, ferric salt, that is, if you take ferric chloride in solution, which is yellow in color, and I forgot to mention the ferrous sulfate is pale green in color. Okay, and then you add again sodium hydroxide to it, you will get a reddish brown precipitate of ferric hydroxide, and sodium chloride will be formed. And when you put excess of caustic soda, it will still remain insoluble. So now, if you are given a blue colored compound, that is copper sulfate, to it you add sodium hydroxide, you will get a pale blue colored precipitate, which is copper hydroxide, and sodium sulfate is formed, which is soluble in water, so it is colorless. So if you put excess of sodium hydroxide, it is still insoluble. Okay, now you are given zinc salts. Okay, so to zinc sulfate you add sodium hydroxide, you'll get a white gelatinous precipitate. Gelatinous, I already told you, jelly like. Okay, of zinc hydroxide and sodium sulfate. The gelatinous white precipitate, it dissolves when you add excess of sodium hydroxide. So zinc hydroxide, the precipitate formed in excess of sodium hydroxide, will form sodium zincate, which is colorless, that is, it will dissolve. Okay, next is lead salt. Now if you take lead nitrate, and again you need to put sodium hydroxide, you'll get a white precipitate of lead hydroxide, and in solution you'll get sodium nitrate. And again, when you put excess of sodium hydroxide, the white precipitate, that is lead hydroxide, will dissolve. So here you can see, and when it dissolves, what is it forming? Sodium plumbite. Okay, so next we come to ammonium salt. When sodium hydroxide is heated with ammonium salt, ammonium gas is evolved. So ammonium chloride, you heat it with sodium hydroxide. This is heat, you'll get sodium chloride, water, and a pungent, bad smelling gas, which is ammonia. If you take ammonium sulfate also and you add sodium hydroxide and you heat it, you'll get sodium sulfate, water, and ammonia, which is a pungent smelling gas. Okay, so potassium hydroxide, which is caustic potash solution, also shows similar behavior. Whatever we discuss, you will be getting the same type of result. Just like sodium hydroxide reacted with certain salts, metal salts, to form precipitates, in a similar manner, ammonium hydroxide also acts on certain salt solution to form precipitates. Okay, so precipitate, when we add ammonium hydroxide solution to the solution of metallic salt, precipitates of their hydroxides are formed. Again, they have a distinct color by which we can identify them. Some precipitated metallic hydroxides again are soluble in excess of ammonium hydroxide due to the formation of amino compounds after it reacts with excess of ammonium hydroxide. Now, when we take any calcium salt and add ammonium hydroxide to it, you will see that no precipitation takes place even when excess of ammonium hydroxide is formed. Why? Because the OH minus ions formed by the ionization of ammonium hydroxide is so low, so less, that it cannot precipitate the hydroxide of calcium. Okay, now moving on to iron salts, when we take ferrous sulfate, which is green in color, okay, and add ammonium hydroxide to it, you will see a dirty green precipitate, okay, that is ferrous hydroxide. This precipitate does not dissolve in excess of ammonium hydroxide, and together with that you get ammonium sulfate, which is in solution. Similarly to ferric iron, ferric salts, that is, here we have ferric chloride, which is a yellow solution. You add ammonium hydroxide, you will get a reddish brown precipitate of ferric hydroxide, which is again insoluble in excess of ammonium hydroxide, and ammonium chloride is found in the solution. Similarly, you take another yellow solution, which is ferric sulfate, and add ammonium hydroxide to it, you will get a reddish brown precipitate of ferric hydroxide and ammonium sulfate in solution, which is colorless. Okay, and you know ferric hydroxide is insoluble in excess of ammonium hydroxide. Okay, now moving on to copper salt, if you take copper sulfate and add ammonium hydroxide to it, you will see a pale blue colored precipitate of copper hydroxide formed, and ammonium sulfate, which is again colorless. Okay, now when you put excess of ammonium hydroxide, the pale blue precipitate, that is copper hydroxide, will dissolve. So here you can see, due to the formation of tetramine copper 2 sulfate. So this dissolves in excess of ammonium hydroxide and water will be formed. Okay, and copper hydroxide in excess of ammonium, this is the blue precipitate, in excess of ammonium hydroxide, tetramine copper hydroxide, and water will be formed. So this reaction, remember children, is the characteristic property of copper ions and is used for the detection in qualitative analysis. Now zinc salts. Zinc sulfate, which is colorless, does not have any color, with ammonium hydroxide, you will see a white gelatinous precipitate of zinc hydroxide formed and ammonium sulfate. And remember, this white gelatinous precipitate of zinc hydroxide will dissolve in excess of ammonium hydroxide. Here you can see with the formation of tetraamine zinc 2 sulfate, which is dissolved in the water. So zinc hydroxide, ammonium hydroxide forms tetraamine zinc hydroxide, which dissolves in the water. Now lead salts, if you take lead nitrate, which is again colorless, and add ammonium hydroxide to it, a white precipitate is formed, which is lead hydroxide, and ammonium nitrate is formed. Certain alkalis react on certain metals to form a soluble salt and liberate hydrogen. Okay, like metals like zinc, aluminium, and lead. And remember, when we take the alkalis, it must be hot and concentrated. So zinc reacts with hot and concentrated sodium hydroxide or hot and concentrated potassium hydroxide to form sodium zincate, which is colorless and liberates hydrogen with effervescence, and it burns with a pop sound. Or if it is potassium hydroxide, then potassium zincate is formed with the liberation of hydrogen. Similarly, aluminium reacts with boiling caustic alkali solution, sodium hydroxide in water, it should be boiling, to form sodium meta-aluminate, which is again colorless and liberates 3 molecules of hydrogen. Okay, and with potassium hydroxide also, it forms potassium meta-aluminate with the liberation of 3 molecules of hydrogen. Aluminium reacts with fused alkali. Fused means melted. Okay, here it was put in water, but fused means it is melted alkali to produce sodium aluminate. So aluminium with sodium hydroxide in the melted state forms sodium aluminate and 3 molecules of hydrogen. Lead reacts with sodium hydroxide or potassium hydroxide it forms sodium plumbite or potassium plumbite, and it releases hydrogen. The action of alkalis on metallic oxides. Now, oxides of most of the metals, are basic in nature, because remember, I have told you in the class also, bases are the oxides and hydroxides of metals. So, they dissolve in water, forming hydroxides. If they dissolve in water, they are known as alkalis. Okay, so these metal oxides and hydroxides, they neutralize acids but do not react with bases. Okay, for example, sodium oxide reacts with water to form sodium hydroxide. Sodium oxide reacts with hydrochloric acid to give sodium chloride and water. Sodium hydroxide reacts with hydrochloric acid to give sodium chloride and water. A few metallic oxides and hydroxide shows double character. That is, they show acidic as well as basic character. So they are known to be amphoteric in nature. For example, zinc oxide and zinc hydroxide react both with acids as well as alkalis, okay, forming salt and water. So you can see zinc oxide with hydrochloric acid, zinc chloride and water, zinc hydroxide with hydrochloric acid, zinc chloride and water. Again, zinc oxide reacts with a base, sodium hydroxide, to give sodium zincate and water. Zinc hydroxide again reacts with sodium hydroxide, which is an alkali, to form sodium zincate and water. So when we talk about amphoteric oxides, we are talking about amphoteric oxides and hydroxides. We are talking about the compounds which react with both acids as well as alkalis to form salt and water. Okay, so amphoteric oxide, you can see here zinc, I already showed you, zinc oxide with sodium hydroxide, zinc hydroxide with sodium hydroxide to form sodium zincate and water, and zinc hydroxide with potassium hydroxide, zinc oxide with potassium hydroxide, which is a base, an alkali. It forms potassium zincate and water. Here also potassium zincate and water. Now next is aluminium oxide, which is white in color, reacts with sodium hydroxide, okay, to form sodium meta-aluminate and water. Aluminium hydroxide with sodium hydroxide forms sodium meta-aluminate and water. Similarly, aluminium oxide with potassium hydroxide forms potassium meta-aluminate and water, or if it is aluminium hydroxide with potassium hydroxide, it forms potassium meta-aluminate with water. Lead oxide, which is yellow in color, with sodium hydroxide forms sodium plumbite, which is colorless and soluble, and water. Lead hydroxide with sodium hydroxide again forms sodium plumbite, which is colorless and soluble, and water. Lead oxide again, which is yellow in color, with potassium hydroxide or lead hydroxide with potassium hydroxide forms potassium plumbite and water. So analytical chemistry is completed, children. Your assignment for this chapter is to write down all the equations that you see in this chapter and please submit it on the 25th, that is this Saturday, and you know your time, that is 11 a.m. in the morning. Okay, till then children, stay safe. God bless you.